We continue in the Learn How to Code course offered by Codecademy in the Basics of Programming 1 section. Moving on to the operators lesson. The lesson begins with the introduction of using operators to make calculations. 4 common operators are introduced that most people are familiar with already. Addition, subtraction, multiplication, and division. Though we are already familiar with these 4 operators in real life, we want to utilize these operators to solve problems, essentially. One such example is the need to buy some apples for a fruit salad recipe. For example, in this example, the recipe calls for 6 apples. However, the apples only come in bags of 5. So then the question becomes, assuming that you only buy the minimum number of bags needed for the recipe, how many apples will you have left over? We can actually use variables as they relate to operations to actually solve this problem. First, we define the fact that the apples, written here as the apples variable, is equal to the number or constant of 5. Then, with that being said, so 5 are basically the number of apples that come in one bag. Then we define the second variable, my underscore apples, basically being equal to the number of apples bags, number of apples rather, the variable multiplied by 2. So the multiplied by 2 operator is being used to define my underscore apples. But then our answer, the answer we require for this problem is how many apples we actually have left over after the apples are used in the recipe. So the answer variable is equal then to my apples, the total number of apples we have essentially, subtracted by 6, because as we can recall, 6 apples are needed for this recipe. So then in this example, the answer would be then simply 4, because it's 10 minus 6, which is equal to 4. My apples being 10 because it's 5, the product of 5 and 2, right here. So basically we solved this problem involving the apples, or rather the leftover apples, using strictly variables as they relate to operators. So then this interactive example is asking to calculate how many apples are needed for the fruit salad. Well, this number can vary depending on the number of servings. So if, for example, if the fruit salad serves 2 to 4 people, we'll need 4 apples. But if you're making it for a party, which is maybe as many as 8 people, you would then hence need to double the recipe. So let's give that example. Let's demonstrate that example. Party of 8 people. So let's add that. Number of apples needed, 8. If we keep adding parties of 8, the number of apples increases by 8 linearly, 32, etc. But if we only need a fruit salad for, let's say, 4 people, we only need 4 apples. An additional 4 people, 8, 12, 16, etc. So as you can see, the number of apples relates operationally to the number of people at the party. Moving on. Moving on. So here we're discussing how to use operators actually to get different outcomes. So these are essentially more advanced Boolean operators. We can actually meaning we can evaluate multiple Boolean expressions simultaneously. So instead of looking whether one relationship is true or false, as in the case with the fruit salad examples, we're actually going to look at if several relationships simultaneously and relating those relationships with the same logical operators, less than, greater than, or equal to, with the same goal of determining whether the overall expression is true or false. So there are 3 main ones, and so both expressions, in order for the result to be true, both expressions have to be true, both. I give an example, 4 being greater than 1 and 2 being less than 7. Because both of these operators are true, the result is true. Or operator, kind of the opposite of and in the sense that only one of the 2 expressions, or it could be more, but in this case it's 2 expressions, returns true. Then the result is true still. So we know that 8 is greater than 6. But what about 3 being greater than 6? It's not. But because the first operator or operation was true, it still evaluates, the end result is still true, even though the second operation is false. It doesn't matter. In the sense, true kind of still results in the overall operation to be true. And finally, we have the not operator. And whatever the result is, it's going to return the opposite of it. So if you start inside, in the inside expression, 1 is less than 3, well, that is true, but not essentially negates it to false. So if the inside was false, the not would also then similarly negate it to true. Just does whatever the opposite operation of the inside expression is. So in the case of fruit salads again, kind of the situation becomes more complicated because we want to include here both types of fruit. So if it's including both types of fruit, strictly three apples and 2 oranges, we would need and for that. Both 3 apples and 2 oranges. If you only had 3 apples but no oranges, or a different number of oranges, say 3, this would be false, but we want it to be correct. So that's why we put and here, both of them. Simultaneously. Second one, applesauce, a recipe that includes apples. Well, if we start with 0 apples and we want applesauce to be the result, we'd need not, because it's essentially the opposite operation. From 0 apples to any number of apples. Just says apples. See how it just says apples? Any number of apples. It doesn't define the number. So then the opposite of that would essentially be 0 or not operation. Thirdly, in the case of making fruit juice, if you can use if the recipe calls for either, so the keyword is either apples or oranges, makes sense to use the or operator because it's essentially apples are optional and at the same time oranges are optional, so it can be either or, but one of them, the minimum of one of them is required for the fruit juice recipe. Moving on to the next step. So the last step is about putting it all together with all of our different expressions that we learned. Essentially, the instructions ask to first create a variable called orange and set it equal to 4. So below this note here, I'm going to do that. Variable orange is equal to the number 4. The next instruction is actually to decrease the number of oranges from 4 to 2. Save the result to the orange variable again. So below the note that begins with decrease on the compiler, I'm going to write that orange equals the first variable orange minus 2. So then the last step is simply to run the code and see how many oranges appear on the screen. The example given with regard to apples, and actually apple variable, is explained how apple is equal to 1, but then the same variable apple is actually equal to the previous variable apple with the addition of 2. So that's a very similar operation and method that we employed with the orange variable. So we're going to run it and see what happens. And there we are. Our result is the number of apples is equal to 3. The number of oranges is equal to 2, just as we had expected when we decrease the number of oranges from 4 to 2. Hence, this compiler successfully ran the code, just as we had anticipated per the instructions. So in review, we discussed how there are different kinds of operators, some of which are arithmetic in nature, meaning they're essentially used to perform calculations, whereas other operators are used to compare and evaluate different types of information, as in the case of Boolean operators or comparison operators, which have a Boolean nature to them, meaning the evaluation of something being either true or false. And logical operators kind of take the Boolean and comparison operators to another level in the sense that they determine a logical state of a combination of simultaneous Boolean values or expressions. So in review, these types of operators constitute the building blocks of almost every computer program. So in review again, as a quiz, what is an operator? An operator is simply a symbol that performs calculations. Addition, subtraction, division, and multiplication, namely. A logical operator and a comparison operator evaluate which data type. They are Boolean in nature. Boolean simply meaning the outcome of something either being true or false. That's all a Boolean means. Next, if you have 8 plants, meaning the variable plants is equal to the number 8, which of these statements evaluate to true? Well, plants have to strictly be equal to 8. Everything else, all these other operators are not consistent with that logic, with the result being true. Next, arithmetic operators are used to make calculations, as we previously discussed. Hence the word arithmetic. You have 5 forks and 3 spoons. Fill in the blank to create the correct comparison expression. So see the word and. So, and also see that 5 is greater than 3, or also, and 3 is also less than 5. So we want to use the less than symbol to represent 3 spoons being less than 5, which would be this one. There's 2 ways of reading it. Forks, the number of forks is greater than the number of spoons, or the number of spoons is less than the number of forks. But in this case, it's read from left to right, so you would say then the number of forks is greater than the number of spoons, but both statements are technically true. And that concludes the operator section.